I think we have learned up to the preparations, right? Preparation of alcohol and the preparation of
Yes, ma'am.
phenols, right? So today we are going to learn for the reactions, okay, and the properties of alcohol and phenols, okay? Chemical and physical properties of alcohol and phenols. Fine. And that first of all, we are going to learn about what? Physical properties. Okay. So what are the physical properties about the alcohol and the phenol? Yeah. Basically, we have to think about the density, right? Then boiling point. Apart from that, solubility, etc. Okay, fine. So if you see this phenol and the alcohol, these are what organic compounds, right? Yes or no? Alcohol and phenol is what? Organic compound. Have you heard this rule? Like, dissolve, like? Yes?
Yes, ma'am. Yeah.
Means generally what? Organic compound get dissolved into organic solvent and inorganic compound get dissolved into inorganic solvent. Correct?
Yeah, ma'am. Yeah, polar into polar and non-polar into non-polar.
Yes. But then here what happened? If you see the solubility of alcohol, it is completely miscible into the water. Right? Yes or no?
Yeah. Yeah.
Might have heard about these drunkards, people, those who drinks regularly, they mix it with the water and drink, right? You might have heard of.
Yeah.
Yeah. So it's completely miscible in a water. Why this happened? Though it is organic compound, it's happened due to this.
Hydrogen bonding?
Yes. It's happened due to hydrogen bonding. Which type of hydrogen bonding? Hydrogen bonding is of different types, right? Two different types. Already I have explained you. First one is
Inter
what?
and intra.
Yeah, intermolecular, and another one is a intramolecular. So if you see the alcohol, one alcohol molecule ROH, and this is suppose another alcohol molecule ROH, right? And if suppose water molecule somewhere HOH, right? So what happened? This hydrogen and oxygen will form the hydrogen bonding. Electropositive and electronegative atoms will be form an electrostatic force of attraction in between them. This force of attraction is quite weak and it is called as the intermolecular hydrogen bonding. It exists into the alcohol, even it in a phenol, and hence it is miscible or dissolves into the water. Why I have used word miscible? What do you mean by miscible? What is the basic difference in between miscible and soluble? Are you aware about it? Aditi? Aditi? Am I audible, beta? Aditi?
Ma'am,
Hello?
can you hear me?
Yeah, now.
Ma'am, miscible, it means it completely dissolves into the solvent, like it forms a homogeneous mixture, I guess.
Both are homogeneous mixture. Soluble. So whenever I say something is soluble into something, that time also it is homogeneous mixture. And when I say something is miscible into something, that time it is also homogeneous mixture. The basic difference in between the states of matter, when your solid get dissolved into liquid, that time you can say it is soluble into that particular solvent. And when your liquid get dissolved into another liquid, that time you have to use the word miscible. Got it?
Okay. Yeah.
Yeah. When solid dissolve into liquid, that is soluble. And when liquid dissolve into liquid, that time it is miscible. Clear? It is very basic. You should be aware of it.
Yeah,
Fine.
ma'am, got it. Yeah.
Yeah. I hope you understand about why alcohol and the phenol get dissolved into water. It's due to
Yes,
hydrogen
ma'am.
bonding. Now,
We learned it last year.
one more property we have learned about, that is what like I have written there. That was about what? Boiling points. Right? Boiling point of alcohol and phenol. So what happened about the boiling point? Boiling point of alcohol and phenol increase with increase in number of carbon atom. Means if number of carbon atoms increases,
Longer the chain, higher the boiling point.
yes, BP is also increases. BP means boiling point. Correct? Yes or no? Why this is? If chain would be longer, if chain increases, your boiling point increases. What is the reason behind? Chain or ring size, if it is increases, your boiling point would be increases. Because when chain would be increases, it
More
will
number
increase
of carbon
what?
atoms are increased.
It will increase surface area.
Yeah.
Right? When surface area increases, it will require greater force to break bond, or greater energy would be required to break a force of attraction in between carbon-carbon chain. And hence your boiling point is increases. Understanding? And if we see the vice versa, means as surface area increases, what we see, your boiling point would be increases. If surface area decreases by branching, that time what happened? Boiling point would be decreases. This is for increase.
Yes, ma'am.
And this is for decrease. Right? If your branching is increases, what happened? Boiling point would be decreases. Clear? Yes? Yes or no?
Yes, ma'am.
Now we are going to go to learn about the chemical reactions of alcohol and phenol. These were just basic physical properties. Now we are going to learn about the chemical properties of alcohol and phenol. Fine? In that, we are going to see reactions of alcohol and phenol. Right? Chemical reactions of alcohol and phenol. In that, how alcohol has been reacted, that we are going to see. First, you should be aware, like alcohols will be react in two different ways. It can be act as a nucleophile, and even it can be act as a electrophile, right? So alcohol has a two different way to react. In the first way, it can be act as a nucleophile, right? And in another way, it can be act as a electrophile. So whenever it act as a nucleophile, it act as an electron-rich species, right? Sorry,
Yes.
I have written wrong spelling for this. Yeah. Electron-rich species. And whenever it acts as an electrophile, that time it will be electron deficient.
Deficient.
Yeah. Okay. So whenever it acts as a nucleophile, how it will be react? See, this ROH. In this electron-rich atom is nothing but what? Oxygen. It has a lone pair, correct? Yes. And it will be react with what? Another alkyl group, Ne, present into the nearby. Okay, suppose here maybe X halogen would be present. If halogen would be gone, it become electropositive spaces. So your oxygen would be attack. Sorry, in this case, your oxygen would be attack onto the carbon, and you will get the substrate, right?
Yes,
Yes, sir?
ma'am.
Yeah. So you will get here R, O, H as it is. It become positive because valency of oxygen would be only 2. But then it extended to what? 3 by the attack through the lone pair, isn't it? And hence, as it is electropositive, it will lose this hydrogen later and you will get the product in that way. R, O, C, and this is nothing but your substituent present onto the carbon. Correct? Yes or no?
Yes, ma'am.
This will
Yeah.
be minus H plus. Clear? So this reaction is the way when your ROH or the alcohol act as what? Nucleophile. Whenever it acts as a nucleophile, what does attack? Oxygen will be attacked onto the carbocation. Okay. It will attack onto the carbocation or any of the substrate, which is electron deficient. Now, what happened when it acts as a electrophile or electron deficient species? Okay. In that case, what will be happen whenever it acts as an electron deficient species? Suppose R, CH2OH. This is your electron deficient species. It acts as electrophile. It acts as electrophile. In that case, it get protonated. How it will be get protonated? If H plus is present into its surrounding or into the solution, this oxygen get protonated and it will be formed R, CH2O, HH. Again, in this case, what happened? Oxygen's valency would be 2. Should be 2, but then it become now 3. And hence, it bear a positive charge. Clear? Yes or no? Now, it become an electrophile due to the positive charge. And on this, your any another nucleophile would be act. Suppose your halogen, any of the halogen would be attacked on this carbon. Here on this carbon, it will attack. And this oxygen would be depart with this 2 hydrogen. So 2 hydrogen and 1 oxygen is nothing but what? Water molecules. So it would be dehydrate the molecule. Water molecule would be removed and you will get this as a product. R, CH2, Br. Correct? Yes or no? Understanding. So when nucleophile based on the cleavage, when it acts as a nucleophile, what happened? Your OH bond is get cleavage, and in certain reaction, your carbon and oxygen bond will be like break. Okay. So
Yeah,
based
ma'am.
on
Got
the
it.
cleavage of OH and CO bond, the reactions of alcohol and phenols may be divided into 2 groups. Understanding? These are the 2 different reactions of alcohol when it acts as a nucleophile and when it acts as an electrophile. When it acts as a nucleophile, that time what happened? Your oxygen would be directly attacked to the carbocation or the substrate, right? In this case, your RO bond will not be break, right? But then in another means carbon oxygen bond will not be break. Here what happened? Oxygen and hydrogen bond would be break, isn't it? Are you able to see this oxygen and bond? This oxygen and hydrogen bond would be break in this case when it act as a nucleophile. And when it act as your electrophile, that time your carbon and oxygen bond get break, right? This bond will be break, isn't it?
Yes, ma'am.
Yeah. So on the basis of that, the reactions of alcohol and phenol is classified into 2 different type of cleavage involved reactions. In that first cleavage is reaction involving oxygen and hydrogen cleavage bond. Okay. And another would be reaction involving the cleavage of oxygen and R group or else oxygen and carbon group. Understanding? So that we have to see in detail. Shall I erase it or you wanted to write it?
Ma'am,
Aditi,
already done. Yeah, I've noted it down.
now what we are going to see in this case, first type of the reactions, reaction involving cleavage of oxygen and hydrogen bond, right? So this bond would be great break in this kind of reactions. So in that, the first reaction which we are going to learn, that would be acidity of alcohol and phenols. Acidity of alcohols and phenols. See about it, what is given to you? Means whenever reaction with metals happen, that time acidity of alcohol and phenols plays really very important role. Alcohol phenols react with the active metal such as a potassium, right? Sodium.
Yes.
Then apart from that, aluminium. These are the active metals, right? And it will be yield into corresponding alkaloids. Whenever your alcohol and phenol react with the active metals like potassium, sodium, and aluminium, it will convert it into their alkoxide or phenoxide, right? And hydrogen. So what sort of reaction it would be? Check it. Generally, suppose you have your alcohol ROH. Okay, purposely I have written them separately because we have to show this bond cleavage, right? Yes or no? Oxygen and hydrogen cleavage we are going to show. Now, whenever you react it with the sodium metal, what happened? You will get RONA. So as we know that hydrogen is a diatomic gas, it will not be released just hydrogen. Nascent hydrogen will never be removed, and hence hydrogen will always go into the H2 form, correct? And hence to make it H2, we have to balance this reaction. So how many hydrogen should be released? 2. And in your substrate, only 1 is there. So you have to take 2 molecules of ROH. And hence for 2 ROH, you need 2 sodium, isn't it? And this is also need to be multiplied by 2. This is what? Sodium alkoxide. Clear? Yes? This is happened when your alcohol is reacted with a sodium metal. What will be happen when it react with aluminium? Example is given, tertiary butyl alcohol, if I have written here. What is the structure for tertiary butyl alcohol? C, CH3, CH3, CH3. Okay, this is tertiary butyl group. It will be attached to your alcoholic functional group. Then it is called as what? Tertiary butyl alcohol. Right?
Yes, ma'am.
Now, when it will be reacted with aluminium, you will get what? In the same way?
We'll get it in the same way, right? Instead of Na,
Yeah.
we'll just write Al. And
So that will
H2
be what?
gas.
That will be what? Aluminium tertiary butoxide, correct?
Yeah.
You will get aluminium tertiary butoxide. But then you have to balance the reaction. O, it will go with what? Al, isn't it? But then how many substrate would be essential to balance the valency of aluminium? What is the
3.
valency of aluminium? 3, correct?
3. Yes,
Yeah.
there will be.
Yeah.
We'll have 3 molecules of
You take these 3
butyl oxide.
to balance the aluminium. How many molecules of this tertiary butyl alcohol you should take? 3 you are going to take or 6 you are going to take? 6 you should take. Why 6 you should take? I'll let you know. Here, you can check how many hydrogen should be released. H2.
Okay, H2. So there will be 3 molecules. We'll have 6
Yes.
hydrogen molecules. So we'll get 6.
So it becomes 6 hydrogen. You will get 3 H2, right? And for the balancing,
Yeah.
aluminum also need to be there. How many?
2.
2.
So
Got
2,
it?
and the total will be
Yeah.
2.
So these are the 6 molecules. These are only 3. So to multiply, this need to be multiplied by 2. Your aluminum also get balance and your substrate also get balance. Correct?
Yeah.
No. So this is aluminum tertiary butoxide. Fine. Clear?
Yes, ma'am.
Shall I erase it?
Yes, ma'am.
Fine. Now what happened with the phenols? Addition of this with the phenol, it will give you phenoxide, right? So this is your phenol. Alternate double bond, it's a benzene. OH would be your functional group. It becomes phenol, correct?
Yeah, the
Reacted with the sodium. What happens?
sodium will
Convert into
replace H.
sodium
And
phenoxide, correct?
yes, sodium
The
peroxide.
oxygen and hydrogen bond would be break, and instead of hydrogen, there would be sodium metal, correct?
Yes.
And here only one hydrogen, and hydrogen would be released as a H2. And to make it H2, what we have to do? We have to take 2 molecules
2
of
molecules
OH.
of phenol.
Yes. 2 molecules of alcohol, alkoxide will be formed, and to balance, we have to multiply sodium as well with 2. This is what? Sodium phenoxide.
Yes, ma'am.
Yeah, please write down. So this happens with the sodium, not only with the sodium. Whenever your phenol molecule react with sodium hydroxide, that time also you will get the sodium phenoxide. Understanding? Suppose this is your phenol and you are reacted it with the sodium hydroxide. Sodium hydroxide formula would be NaOH. So whenever it react with the NaOH, that time also it will convert into sodium phenoxide. Your ONA. Now here OH and this is H. It will form what? Water molecule, H2O. Clear? This is sodium phenoxide.
Done, ma'am.
Fine. Now the next point we are going to learn, that is about acidity of alcohols. Shall I erase it?
Yes, ma'am.
Now, acidity of alcohols, if we see, here is your R group. Okay. Yeah. This R group may change. It depends. If your R attached to your C, okay, here it will be suppose CH2OH. This would be your primary alcohol, correct? Isn't it? Then I'm going to write here 2R group on the carbon and only 1 hydrogen. This attached to OH. This would be your secondary alcohol, correct? And another one would be your carbon. It has 3 alkyl group R, R, and R. It is attached to your OH. This will be your tertiary alcohol, correct? Now in this 3, what is given? The acidic character of alcohol is due to the polar nature of OH bond. This bond is there, right? It has a polar nature. Why? Because electron density is towards the oxygen and less towards the hydrogen, right? And hence it become polar. It make it polar nature. Or else we can say it can be more due to positive character onto the carbon and negative character on the oxygen. That is also we can consider. This is a negative and this is your positive character, correct? Yes or no? Positive and negative delta. Yes or no? Aditi, are you understanding what I'm trying to say?
Yeah, ma'am.
Yeah. Now, an electron releasing group like CH3, C2H5, if it is present into the substrate, it increases the electron density on oxygen, tending to decrease the polarity of OH. Have you heard about the inductive effect?
Yes, ma'am.
Yeah, you learn about the inductive effects. If your alkyl groups are increases, this is your first alkyl group, these are your second alkyl group, two alkyl groups, sorry, in this, and here are how many? Three alkyl groups are present. If your alkyl groups are increases on this carbon, it will give the electron density towards this carbon, right? And because of that, its positive character
Yes, ma'am.
yeah, because of that, its positive character get decreases and your bond become less polar. Okay, but it won't happen in a primary more. It will be happen more in secondary and most into the tertiary due to three alkyl groups are present. If one alkyl group is present, that time electron density is less towards the oxygen. But then it will be increases when there would be two alkyl group, and it would be more or we can say most whenever it will be three alkyl group due to inductive effect, and hence polar nature of the carbon and oxygen bond would be decreases, and hence your acidity is also decreases. So if you have to compare the acidity, how are you going to do? Primary is a more acidic as compared to secondary, and secondary is more acidic as compared to tertiary. Understanding?
Yes,
Yes.
ma'am. Like,
Yeah.
more the number of R groups, less the acidity of the alcohol.
Yeah. Why it is so? Due to electron density provided by that alkyl group towards the carbon, electron deficient, it become less polar. Clear? Clear?
Yeah, ma'am.
Yeah. Please write down if you want to write. Now, alcohols are, however, weaker acid than the water. This can be illustrated by the reaction of water with the alkoxide. What I said now, shall I erase it?
Yeah, ma'am.
What I said now, alcohols are weaker acids than the water, I said. Why it is so? How we can say if we react the alkoxide, RO, whatever it would be metal, suppose RO minus, metal if present that would be positive, right? So this is a base, right? Whenever it reacted with H2O, what it will be formed? Immediately it will take a hydrogen, ROH.
Yeah, it will take up a hydrogen.
Yes. And it
Plus
will be
OH minus.
OH minus. And this OH is nothing but OH minus is nothing but what? Conjugate base.
Yes, ma'am.
It will be conjugate base of the acid. Means what? Water act as a acid in this reaction. Okay. And OH is what? Conjugate base of that acid. And hence what I said, alcohols are weaker acid than the water. And that we can prove by reacting the alkoxides, right? Metal alkoxide with the water. Clear? Fine?
Yes, ma'am.
Yeah. By this reaction, what we come to know? That water is a better proton donor. Okay. That is a stronger acid than the alcohol. Also, in this reaction, we note that the alkoxide ion is a better proton acceptor than the hydroxide ion. We suggested that alkoxide are a stronger bases, whereas water is a acid. Fine. Now we are going to see the acidity of phenols. Correct? This is about alcohol. Now we are going to see the acidity of phenols. Shall I erase it?
Yes, ma'am.
Fine. So this is also regarding the donation of hydrogen, right? Proton donor. Who would be the proton donor? Who would be the proton acceptor? On the basis of that only we will decide which is base and which is acid, correct? Yeah. So structure of phenol is there with you. Just a simple task I'm going to give you. You have to draw the canonical forms of this phenol. Let me see how you're going to do. Already I have taught you this. I hope you're able to do it. Here are the lone pairs. Go for it and draw the canonical forms for the phenols.
Ma'am,
Just
the electrons from O will form a double bond with the carbon. There will be a double bond between O and C, and the double
do me a
bond.
favor currently. Just draw it on a paper and share with me. I'll give you the
Okay. Yeah, ma'am.
authority to share. Or else you can send it to me in a chat as well. The snap of
Yeah,
it.
ma'am. Just a second.
Yeah. Because orally I won't understand what exactly you have done on paper. Have you done?
No, ma'am. Just give me another 2 minutes.
Okay, hurry up.
Ma'am, I'm just sending you the picture.
Yeah, please. Okay, you're sending on WhatsApp or in chat?
In the chat, ma'am.
Okay, I didn't receive yet. Okay. So we are just comparing about your alcohol and the phenols now, right? Acidity of alcohol and phenols. So if you delocalize these electrons, what happened? It will be formed bond over here. And these electron would be goes where? Exactly at the ortho position, right?
Yeah, ma'am. I've sent it.
Yeah, I'm checking it. Okay, ortho position, fine. Para position and again ortho position. Very good, correct. But then only one mistake is happened, beta. You have not shown the positive charge on the oxygen. Right? Aditi?
Okay, yeah. Yeah.
What happened in this case, as electron has been utilized to form double bond over here, right? Oxygen and carbon, valency of oxygen
Yeah,
is in
there will be a
it will
positive
generate
charge on
positive.
oxygen.
Yes. Clear? Fine. So this is your again phenol structure, and here it is your negative charge. Now it will form a double bond over here, and delocalization is happen at the para position of electrons, right? It will goes at the para position. I hope you have drawn the same. Yeah, I have seen you have drawn the same only. But then the point is what? Only just this point was missing, positive charge. Clear? It will go to the ortho position now. Again. Correct? Yeah. Now what we come to know in this, Aditi? Are you there? Aditi?
Yes, ma'am.
Yeah. So in this case, what you come to know, this proton is not available immediately to donate. Right?
Yeah.
So conjugate base is what? Which can donate the proton and form OH minus ions in that, right? Yes or no? We have seen into the alcohol. Alcohol easily donate the proton, but then here donation of proton will not be happen easily because delocalization of electrons takes place, right? And your oxygen become here electropositive. Yes? Yes or no? And because of
Yes,
that,
ma'am.
these phenols are strong acids as compared to alcohols. There are the two reasons for that. First one is what? When you take the phenols, it will be react easily with metals, either Na or NaOH, right? Metal or metal hydroxides, right? And it will be form your alkoxides, phenoxide, not alkoxide. It will be form your phenoxide ions. This already we have seen the reactions, right? And H2 will be released, right? Balancing we will see later. That we are not going to think about the balancing currently. I just wanted to tell you what, when phenol would be reacted with the metal or the metal hydroxide, it will be converted into phenoxide, right? Yes or no? So this is a fast reaction. And apart from that, the donation of proton will not be takes place easily in the phenol, how it is happening to your alcohol. The another reason is what? If you see the alcohol, R is directly attached to OH in the alcohol. But then this R is nothing but what? sp3 hybridized, right? But then in this phenol, your carbon, which is attached to carbon-carbon double bond, is completely joined with your OH group. Means this carbon is nothing but sp2 hybridized, right? And as it is sp2 hybridized, electron density or electron delocalization is happened towards the carbon more. And earlier we have learned what? If electron density or electron delocalization is more towards the carbon, it become more less polar of the bond, isn't it? Polarity would be increases or decreases. Carbon-carbon double bond is there, no? So
Yes,
polarity
ma'am.
increases or decreases? Polarity increases. And even this hydrogen, oxygen also delocalizes the electron among it. Yes?
Yeah.
And because of that, what happened? Due to this sp2 hybridization, due to delocalization of the electrons from the oxygen in the ring form, in the benzene ring in a phenol, what happened? It become more acidic. It will not give its proton easily. And hence it becomes strong acid as compared to alcohol. And vice versa in alcohol, what? This is sp3 hybridized. It gives more electron towards the oxygen, right? Because of that, it become positive, it become negative, right? Electron inductive effect we have learned. Inductive effect is less effective as compared to resonance, because in phenol, we have a resonance effect, right? Due to delocalization of electron. And here we have a inductive effect, right? Yes. And due to delocalization, phenol shows a less acidic character, more acidic character, whereas alcohol shows a more acidic character, as it is bound to sp3 carbon. OH group is attached to sp3 carbon. And in phenol, your OH group is attached to sp2 hybridized carbon. Clear? Yes or no?
Yes, ma'am.
Yeah. If you have any doubt, anything in your mind about, please let me know. Like any point you have not understand about it, then I'll explain it again. Shall I explain one more time? Shall I erase it?
Yeah, ma'am, you can erase it.
Yeah. So basically, you just have to think about this R, OH, and this is your phenol, and this is your OH. What you have to keep it in your mind, this is your sp3 hybridized carbon. This is your sp2 hybridized carbon, correct? It can easily donate proton. It cannot easily or can't easily donate, right? Here it is what? Inductive effect, right? Here it is what? Resonance effect, right? Or else apart from that, you can say delocalization of electrons in ring, right? Because of that, it is strong acidic or strong acid. This is weak acid. Clear? These are the reasons. Okay.
Yes, ma'am.
Now the next thing which you have to learn, that would be esterification. Shall I erase it? So first type of reaction we will finish once we have completed with the esterification. First type of reaction means what? Reaction involving oxygen and hydrogen cleavage. Okay. Shall I erase it, beta? Aditi?
Yes,
Aditi?
ma'am. You can erase it.
Fine. Now, next is esterification. What do you mean by esterification? What is the chemical formula of ester? First of all, you tell me. From there, we will start. R, C double bond O, O, R. This R or R and R dash can be same or can be different, correct? This is a general formula for ester, right?
Yes, ma'am.
Esterification means what? Formation of ester. Alcohol and phenol react with carboxylic acid, then the acid chloride and acid anhydride to form a ester. So it cannot react only with the carboxylic acid. It can be react with carboxylic acid, then it can react with acid chlorides. It can be react with acid anhydride to form the ester. So here reaction should be happening between alcohol and phenol. Structure of alcohol and phenol you're aware, so I'm not going to write it. Generally, it will be ROH and it will be PHOH. PH means a phenyl ring or benzene ring. Okay, fine. Now, it can be react with what? First of all, they said as carboxylic acid. General group for this R, C double bond O, OH. COOH. These are the carboxylic acid functional group. Then another one is acid chloride, R, C double bond O, X. Any halogen would be present over here. This is acid chlorides or acid halides in short. Chloride, if it would be, then this X should be replaced with what? Either chlorine, bromine, iodine, etc. Halogen. And anhydride means what? Acid anhydride. It may be reacted with this group. This is nothing but C, huh? C double bond O, C double bond O, R. This R can be same or different. Most of the time it will be same. This is acid anhydride functional group. Okay, means two carbonyl carbon will be attached with single oxygen in between. Okay.
Yes, ma'am.
That is the acid anhydride. So whenever these three functional groups would be reacted with the alcohol and phenol, you will get what? This ester. So basically, purposely, I gave you the functional groups and the basic general structures of these functional groups. So you should be aware like what exactly it is. Fine. So now we are going to see the reactions. Shall I write down? Have you wrote it? This is what? Carboxylic acid. If you want to write down carboxylic acid. This would be what? Acid chlorides or acid halides. Chloride I won't write because if I have to write chloride instead of X, I should write it here chlorine. And this is acid anhydride. Means two acid from that when if I remove the water molecule, it will form acid anhydride. For example, like this. R, C double bond O, OH. Here R, C double bond O, OH. Right. So this one, this H2O molecule, if I have removed, I'll get this. I have removed what? Water. Water means hydra. I make it anhydride by removing water molecule. So this is called as acid anhydride. Got it? Understood or not?
Yes, ma'am.
Now shall I erase it?
Yeah, you can.
We will see the reactions now. And this what happens, see? Aromatic or aliphatic. Means suppose ROH, if you're reacting, that is for alcohol. And if you're writing AROH, that is for phenol. Okay. If you react it with your RCOOH, what it is? Carboxylic acid. This structure is nothing but what? RC double bond OOH. RCOOH. Understanding? We can write it in this form. Even we can write it in this form as well. Understood? Don't get confused. Clear?
Yes, ma'am. Yeah, ma'am.
Fine. So this reactions would be reversible. What will be happen? You have to form ester in this case. How you will get? R, C double bond O, O, R. And this what hydrogen and this OH group will be form what? Water molecule, correct? Yes or no? R, C double bond O, O, this hydrogen would be removed. Fine, this OH would be removed. This O will be attached to this R group. So you will get R plus H2O. Clear? This can be written in this way as well. RCOOR. This is also ester. This is also ester. In both way you can write it. Okay. Understood?
Yes, ma'am.
Most of the time it can be written as ROCOR. Okay. ROCOR. In this way it would be written. But then the actual way to the like denotation would be this. RC double bond O, OR. Fine. The same way your aromatic means phenol also would react in the same way, only instead of R, there would be aromatic ring. AR, then C double bond O, O, R. Correct? Plus H2O. Clear?
Yes,
Now,
ma'am.
if the same reaction happen with the acid anhydride, what will happen with acid anhydride? I'll show it with a different color. Okay. Now here ROH reacted with what? RCO2 twice. RCO twice O. What is this structure? You know, this one R, C double bond O. Okay, this is 2 times R, C double bond O and 1 time of oxygen. So this is the way to write it in a short form. This acid anhydride. Clear?
Yeah, ma'am.
Fine. Now what you will get here? Again, you should get the ester, isn't it?
Yeah.
So how you will get ester in this case? R, C double bond O, OR. So this oxygen would be there. It will attack here, any of the carbonyl carbon.
Yeah, and then it will replace it with R.
It will go to the oxygen, isn't it?
Yeah.
If you write it here, any H plus ion, if you introduce it, or that H plus ion can be taken from here as well. Anyhow, it's going to lose, right? This hydrogen would be loose. You will get R, O, C double bond O, R, correct? This is nothing but your ester only. Same way, just wrote into the different manner. Okay, same molecule wrote into the different manner. Means so we are writing from this way. Now I have written in that way. Clear? What else remain? This R, C double bond O and this hydrogen H. You'll get R, C double bond O, OH. This is your side product. This is carboxylic acid. Isn't it? And this is your ester group. And if you are writing the reaction for aromatic ring or phenol, just this R should be replaced with AR. Okay. Please write down the second reaction also with aromatic ring. AR, O, C double bond O, R. Right. This is also ester. If you're done with this, let me know. Then the last reaction we will see. How acid chloride would give us ester.
Yeah, ma'am, I'm done with it.
Yeah. Now check here. Same way, ROH reacted with R, C double bond O, X, right? This reaction would be takes place in presence of pyridine. Pyridine act as a base, okay? Fine. So in the same way, this oxygen would attack here on the carbonyl carbon. This your X group would be removed. You will get R, O, C double bond O, R. Plus X would be removed. This H will be there. It will form HX. Now, if it is Cl, you will get here HCl, right? And if instead of AR, instead of R, that would be AROH, your product would be ARO, C double bond O, R. That's it. This is also ester. This is also ester. Correct? Mm-hmm. Yes or no?
Yes.
Please write down. So what is given to you? The reaction with carboxylic acid and acid anhydride is carried out in a presence of small amount of concentrated sulfuric acid. This reaction is reversible and therefore water is removed as soon as it forms. And reaction with acid chloride is carried out in the presence of pyridine or base, so as to neutralize the HCl which is formed during the reaction. It shifts the equilibrium to the right hand side, and hence introduction of the acetyl chloride or acetyl group CH3 C double bond O group in alcohols or the phenol is known as the acetylation. So acetylation of the salicylic acid product is produces nothing but the aspirin. Acetylation of the salicylic acid gives you what? Aspirin. That reaction I'll show you. So what happened, what they said in the previous reaction, both the reaction, whenever your alcohol and the phenol reacted with the reacted with the carboxylic acid and reacted with the acid anhydride, that is a reversible reaction. And for the completion of reaction or the shift reaction towards the right hand side, we should add the concentrated sulfuric acid or H plus ions in that. Okay. And why that is to be? Because in that case you will you have to neutralize your water molecule. Now, water molecule is to be formed, right? So whatever H plus would be removed, and H2O would be you need to remove it from the reaction, right? And for that reason you should use the H plus ion. That concentrated acid would be bounded and protonium ion would be released. Now, what happened? Why we adding the pyridine in the last reaction, means acid chlorides. So in that reaction, what we are going to produce here? HCl, correct? These are the strong acids. So this acid is to be neutralized by using this pyridine. So when it will be neutralized, reaction shifted more towards the right hand side and your product would be give you more yield in the reaction. Clear? This is base. This base and acid will be neutralize each other. Okay, and your product would be forming a greater yield. That's it. Clear? Hello?
Yes, ma'am.
Fine. So about the salicylic acid, that reaction you write down, then we will stop. Okay. What is the structure of salicylic acid that you should be aware? Okay. Yeah. Salicylic acid is nothing but the phenol. And at the phenol's ortho position, your carboxylic group is present, COOH. Right? This is what? Salicylic acid. Keep it in your mind. And whenever reacted with the acid anhydride, acetyl group is to be introduced that time. CH3, CO. If it would be 2 times and 1 time of oxygen. This is what? Acetyl anhydride, because this is an acetyl group, correct? Yes or no? This group is what? Acetyl group. It should be attached to at the place of hydrogen. Hydrogen should remove in this case. Yes or no, Aditi? Aditi, have you turned on your video?
No, ma'am. I guess accidentally.
Okay. Fine. Now what you will get here? This is your salicylic acid things. The benzene ring first of all. Carboxylic acid will not be affected at all. As esterification happen of this OH group. So O would be as it is. It will be get connected with what? This C double bond O CH3. Correct? Plus whatever remaining things are there. Here CH3, C double bond O, OH. This is a carboxylic acid. This is acetic acid actually. Isn't it? Yeah. So these are the two products you will get in this case. In another way, how you're going to represent it? This is your phenol ring with the salicylic acid. Carboxylic acid, you're going to write here COOH. Here it will be C. This will be oxygen, sorry, oxygen, carbon, oxygen, CH3. This is the ester group which newly introduced. This is acetylation of the salicylic acid, and hence you will get the product as an aspirin. The introduction of this group is called as what? Acetylation. Okay, to form an aspirin. And this is your carboxylic acid. It is also represented as CH3COOH. These both are same. And these both are same. Got it? Yes. So we have seen the reactions involving oxygen hydrogen cleavage of alcohol and phenol. In the next period, we are going to see the reactions involving the cleavage of carbon and oxygen bond for the alcohol and phenol. Clear?
Yes, ma'am.
Shall I erase it?
Yeah, ma'am.
Fine. I'm going to end the class now. I think today your physics teacher is going to take at 8:45, right?
Yeah, ma'am.
Fine. So no issues. Tomorrow, or either tomorrow or any other day, like morning only, we will conduct the class. Okay?
Okay, ma'am.
Fine. Shall I
Thank
end
you.
here?